Before we can execute this program, we need to compile it. In other words, we need to tell the C compiler to translate our source code into what's referred to as object code, or executable program. The method of telling the C compiler to compile and execute a program will vary with different C systems. If you're using a different version of C, then this might vary, and you might want to consult your help facility or your instructions manual to find out the specifics on compiling in your version. Even in the Microsoft Visual C++ environment, there are several ways to compile the program. One way is to click on the Build option on the menu bar, and then click Compile. You will immediately get a message that says this build command requires an active project workspace. Would you like to create a default project workspace? Since C requires this project workspace, we need to answer yes. Then we need to specify where we want this program to be saved, since we have not done so prior to this. I have a subdirectory or a folder on drive C called VTC C++ that I will store my programs. I will call this demo1.cpp and store it into this folder. Once the program is now saved, the compiling begins. As you can see down in my output window, I get the message 0 errors, 0 warnings, which is exactly what I was hoping for. Now that our program is error-free, we now need to test it to see if it actually works. To do so, I can return to the Build option and then click on Execute demo1.exe. And what C has done is created an executable version of my program. I run the program, and it asks me if I want to build the exe version. It says the file does not exist. I need to respond with yes. The program is now running, and as you can see, it has opened the DOS window. And it's prompting me for the first variable. I'll enter the number 4 and press enter, followed by the number 9 and press enter. Now you'll notice that the program ran, but the output did not stay on the screen long enough for me to see the output. To correct this problem, we'll return to the last line of our program, where we said cout the sum of the numbers and then total. We can enter the insertion operators followed by ENDL. This is known as inline. The inline command will advance the cursor to the next line on the computer screen after it displays, in this case, the total of our sum of numbers. It also will serve as a pause to allow us to view the output. So since we've now made this change, let's recompile our program by clicking on Build. Once again, we get no errors, no warnings, and then we can go back to Build and click on Execute. And once again, let's enter some test data. And now, as you can see, the program is indeed working. It tells us the sum of the numbers is equal to 14, and to press any key to continue. And that is the DOS message, which allows us to press any key to return to the C environment. So now we have a working C program. One quick note, you'll notice there is a shortcut button to execute the program. This exclamation point on the toolbar will allow you to execute the program without going through the menu. So that is a shortcut. Also, you can click on Build, and you can either click on Compile, or click on Build, or Rebuild All. All three of these will essentially do the same thing. The compile process will simply compile the program. The build will take that compiled program and build it into an executable file. So if you don't want to be prompted for each step, you can go directly to Build, and it will do that for you. That is, compile and build the executable program. In the next segment, I will introduce a few errors into this program to demonstrate how to handle and how to avoid certain types of errors.